Hi, welcome to myprocesspaper.com. Now let me discuss about the text of the process. Our title is Modification for Probabilistic Generative Classifiers with Data Mining Applications. So our process is another program called data mining. So data mining is nothing but an extraction of selected amount of data. So in our process we are going to fusion of some classifiers. In this we are going to use of two classifiers called as probabilistic classifier and also called as generative classifier. In the probabilistic classifier we are using the conditional probability formula, and also we are using generative classifiers for classifying the results. Now let me discuss about the abstract of our process. Data fusion is the process of integration of multiple data and knowledge representing the same real-world object into a consistent, accurate and useful information. In this paper, we introduce a new way of using classifiers at the level of parameters of classification rules. This technique is based on the use of probabilistic generative classifiers using multinomial distributions for categorical input dimensions and multivariate nominal distributions for the continuous ones. So normally in the dataset we have attributes as a categorical input datasets and continuous datasets. So we show that using two or more classifiers can be done by multiplying the hyper distributions of the parameters and also derive simple formulas for the task. Properties of this new approach are demonstrated with a few experiments. The main advantage of this fusion approach is that the hyperdistributions are retained throughout the fusion process. Probabilistic generative classifier is one of the generative model. It is a model for randomly generating observable data. In this, we modeling the observations drawn from a probability density function and conditional probability density function. Conditional distributions can be formed from a generative model through Bayes rule. Now let me discuss about the complete data flow diagram of our process. So our domain is under the our process is under the domain called data mining. So first we need to collect the training data set for our process. So in our process we are implementing that knowledge fusion process by using the data set called cover data set. So it is one of the forest type data set. In the data set we have a large number of class files. So in the data set we have a 1 to 5 type of class files. So after we collect the training data set, after we have to convert that into the matrix format. After we convert that into the matrix format, we are going to cluster the values in the data set. We are converting the matrix for identifying the neighborhood relationship of objects in the data set. After we split it to the clusters, we are going to apply the probabilistic generative classifier. First, we have to apply the probabilistic classifier for multinomial attributes. After that, in the probabilistic classifier, we are applying the conditional probability formula, that is called probability density function. And after that, we are applying the generative classifier. In that, we apply some decision tree model for classifying the results, that is called generative classifier for some multivariate attributes in the data set. Finally, we fuse the two types of classifiers. After that, we predict the classification results. After that, we predict the total number of classified instances incorrect classified instances by using the both probabilistic generative classifier. This is the data flow diagram of our process. Now let me discuss about the complete demo of our process. First, you have to run home.java. So our title is Knowledge Fusion for Probabilistic Generative Classifiers with Data Mining Applications. So first you have to choose a data set, input data set. Here we are using cover data set. This is the data set we are using in our process. Just enter the data into the database. Then calculate the covariance matrices for calculating multivariate attributes. Here we are calculating matrix for every attributes in the data set. After that you have to classify the matrix values. So here we are calculating the matrix values, and Classify the values by using class labels. For 0 class label, and then for class label 1, here we are calculating and classifying the values. Then here we are clustering the values based on the matrix values. Then here we click the multi. Here we are calculating the multivariate variables to estimate the similarity values between every attribute. Then click multi-nominal variables. Here we are calculating for every cluster values and similarity values in the data set. Then click next. Here we are calculating the conditional probability for the process. Here we are calculating P of A1 shall be P of A and B. Then here we are calculating the P of conditional B for every cluster in the data set. Then here we are going to apply the generative classifier matrix for the information gain, entropy, gain values, then fusion of both decision tree and probabilistic classifier results. So here we are fusing the results. Based upon the fusion results, here we are displaying as a tree format. After that, we predict the results. Then here we are calculating the efficiency for the process. Select the classifier instances, store classifier instances, kappa statistic, mean absolute error, root mean squared error, relative error, relative squared error, total number of instances. So this is the complete demo of our process. Thank you for watching.